All right, so well, I got to get myself out of the way. I don't know where to put myself. Binary covalent nomenclature. All right, so we talked about worksheet 5. This is the naming process. So binary means 2. So all of these compounds only have 2 elements in them. Covalent, they're covalent bonded compounds. And nomenclature means the naming and formula process. Okay, so binary covalent nomenclature. Sounds complicated, but this is just saying this is how we name and write formulas for 2-element covalent compounds. Now, there's a list of rules here, okay? And the list of rules, it's going to seem complicated and not even make sense probably until we just kind of get in and start doing this. So, first of all, it says 2 non-metallic elements. 2 non-metallic elements. If you've noticed, and maybe you haven't noticed, all of our examples so far for covalent, they're all non-metals. We haven't had any metals in these compounds for covalent. And I don't know if you noticed something else. For ionic, all of them had a metal involved. So there's something to keep in mind for in a few minutes. It says the first element keeps its name. Just like ionic compounds, whatever the first element is, that's the first name in the compound. Now, it says the first element gets a prefix if it has a subscript in the formula. Well, if there's a subscript in the formula, that means there's more than one of them. More than one of them, you have to use a prefix. That's what these are. Now, you don't have to memorize these. These will be either on the quiz or on the board while you're taking the quiz. So one or the other. These, though, are the names that symbolize the numbers that would be in the name of the compound so that we know how many of each atom are in the molecule. Okay? I hope you see maybe. Now, again, you don't have to have them memorized, but I mean, some of these should be pretty darn familiar, especially like penta through deca. I mean, that's like math, geometry, shapes, right? Like a pentagon, hexagon, right? 5-sided object, 6-sided object. Now, mono, di, tri, again, I would think those are fairly common. Tetra, maybe you hadn't heard of tetra, except for maybe Tetris. Every shape in the game Tetris is made of how many blocks? 4. Tetra. Tetris. 4. Anyway, so the first element gets a prefix if there's a subscript. We'll get to that. The second element gets the "-ide" suffix. So they're going to end in "-ide", just like all the other naming we did for ionic compounds. It's still going to end in "-ide". And the second element always gets a prefix. So you're going to have one of these on every one of the names of a covalent compound on the second name in the formula or in the compound. Okay, so the best way to do this is just to start. Okay, so in class we were doing this together, and so I said, oh, hey, dihydrogen monoxide. Let's talk about it and figure out what that formula is. And then I said, whoa, this stuff is dangerous, all right? Dihydrogen monoxide. I said thousands of people die from inhaling this stuff every year. It's found, it's used in nuclear power plants. It's found in the ground. It's found in the air. It's found in cancerous tumors. It's found in cleaning chemicals. I mean, it is everywhere, all right? And again, thousands of people die from inhaling this every year. So what could this stuff be? Well, dihydrogen. Di means what? Well, di means 2. Oh, so there's 2 hydrogens. Okay, so the formula has 2 hydrogens. Oh, I got to get me moved over here because, oh gosh, there we go. I get the pen. Oh no, I'm in the wrong mode. and click on this. Okay, so pen, orange, my favorite. And that means there's two H's. Okay, two H's. Monoxide, monoxide. Monoxide. So what's oxide referring to? Oxygen, oxide. Okay, how many of them? How many oxygens? One. Oh, wait a minute. This is H2O. Oh, what do you mean people? What do you mean thousands of people die every year for inhaling it? What happens when you inhale water? It's called drowning. So, yeah. Is it found in nuclear power plants? Yeah. Is it in cleaning chemicals? Yes. Is it in cancerous tumors? Yes, because you're mostly water. And so that means your cells are mostly water, and that means it's in a cancerous tumor. So anyway, but dihydrogen monoxide sounds very ominous. That sounds very dangerous, but it's just water. Okay. We don't call it dihydrogen monoxide, obviously. We call it by the common name water. Now, carbon tetrachloride. Carbon tetrachloride. Notice there's no prefix here before the carbon. No prefix means there's how many of them? One. The names are never going to start with mono. You will never have mono at the beginning because it says the first element gets a prefix if it has a subscript in the formula. Right? There's not multiples. So it's only one. It's one carbon. Okay, so one carbon. Tetrachloride. Tetra means what? Four. That's what the list says, right? Tetra. We talked about tetras. Tetra is four. Chloride. Chloride is referring to which element? Chlorine. So that's Cl. So Cl4. That's one carbon and four chlorines. CCl4, carbon tetrachloride. All right, so now you're supposed to write the correct name for these. Oh, now before we did this in class, we did some building. We were using the molecular models and building some molecules and stuff. So, I mean, if you weren't here, you missed the building stuff. And then we went into this. So, CH4, how are you going to write the name of that? CH4. Well, there's just a C, right? No subscript. No subscript down here. So how many of them? That's one. But we don't start the name with mono. We don't say monocarbon. It's just carbon. So the name, carbon. Carbon what? Well, there's four H's. Yeah, four H's. Carbon. Tetra. Now, how do you say hydrogen in this name? You don't say carbon tetrahydrogen. Remember, you have to replace the suffix with "ide." The question is how much of it. Is it hydrogide? No. Remember, nitrogen, oxygen, and hydrogen, all the ogens, you're going to lose the whole ogen. So instead of hydrogen or hydrogide, it's hydride. Because nitrogen is nitride, oxygen is oxide, so we lose the ogen and just put ide in its place. So carbon, tetra, because there's four, hydride. Carbon, tetra, hydride. Carbon, tetrahydride. And then we have PCl3. PCl3. What's the P? Again, no subscript, so there's no prefix. It's just one of them. And the P is not potassium. Man, people are still doing that. Not potassium. Phosphorus. So it is phosphorus. What's the subscript? 3. What's 3? Tri. Phosphorus, tri. And again, we got Cl again, Cl for chlorine. And so instead of chlorine, it's chloride. Phosphorus trichloride. Now, I guess we already drew dot diagrams for the top two. For 3 and 4, we hadn't. So I guess I'll do a, well, hold on. Carbon, in our molecular models, carbon is black. So I'll put carbon as a 1 and a 2 and a 3 and a 4, which is what you're supposed to know that. And then tetrahydride. So I got to put 4 hydrogens on there. So that's 1 would go here. 1 would go here in this empty spot. 1 would go here in this empty spot. And 1 would go here in this empty spot. Now here's the deal, folks. Please make sure, please, in your dot diagrams, that you're not drawing the dots like in a circle around the symbol. It should be very clear that these electrons are paired and paired and paired and paired on each side, top, bottom, right, left. They all need to look like they're paired up, almost like a box, like you've got a top and a bottom, you've got a right and a left, not just randomly strewn about in a circle. That is not how we draw them, okay? This is how they should look. Paired up close, bottom, top, right, and left, okay? Now, phosphorus trichloride. Okay, well, what's the dot diagram for phosphorus? Hopefully you've already jotted it down. Phosphorus is 1, 2, 3, 4, 5. There's 5 valence electrons in phosphorus. That means there's 3 empty spots. Well, how is a chlorine going to fit into the situation? Remember, chlorines and hydrogens are handy, right? Because all of them, they only have 1 empty spot. All of the halogens and hydrogen, they each have just 1 empty spot, so they can plug in anywhere. So for this, you could have a chlorine. You can have a chlorine right here on this side, chlorine. There's 1, 2, 3, 4, 5, 6, 7. Because remember, chlorine has 7 valence electrons. And so we see there's an octet now. The empty spot on that chlorine gets filled by the empty spot from phosphorus, and the chlorine fills phosphorus's empty spot, so now they share a pair. That means another one can go down here. Chlorine down here, 1, 2, 3, 4. I'm drawing this a little small probably. 4, 5, 6, 7. So hopefully you're getting this. And then the last one can go right over here. And again, 1, 2, 3, 4, 5, 6, 7. And so you'll notice then, I hope anyway, that phosphorus now has 2, 4, 6, 8 around it. Chlorine has 2, 4, 6, 8 around it. This chlorine has 2, 4, 6, 8 around it. This chlorine has 2, 4, 6, 8 around it. Notice they are close pairs that we can easily see the octet. Octet, 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 octet. You don't even have to count them, and you can see the 2 and the 2 and the 2 and the 2. Okay? Make sure that's how you have it set up. Do not, I repeat, do not draw one big blob of dots around it like it's a circle. That's not how this works. It is a pattern that has to be easily recognizable when you glance at it without having to literally count every single dot by looking at it. You should be able to tell that there's an octet by looking, because top, bottom, right, left. All right, moving on. Moving on. Now we have a table here. Oh no, and I'm in the way. I'm in the way, and I locked this thing. Hold on, I'm gonna unlock it. And I'm gonna move it down. Oh, that's perfect. Whoa, what the? I lost it. Oh, there it is. Whoa, I'm gonna lock it now. Okay, now, notice there's a column here that says ionic or covalent. Well, how are you supposed to know that? Well, let me tell you a couple things, okay? Let me tell you a couple things here. If it's ionic, oh no, I lost my pen. Ionic, there's going to be a metal, most likely a metal and a non-metal. And the names will have no prefixes. Oh gosh. No prefixes in the name. Covalent. Only nonmetals. And you will always have prefixes in the names. Always have prefixes. So there's two ways to tell. Whether you're looking at a name or whether you're looking at a formula, there's two ways to tell. Number one, look for a metal. If there's a metal in the compound, it's ionic. And here's the deal. Here's why this is. The metals on the table, their valence numbers are 1s, 2s, and 3s. They're almost empty. They cannot share their way to a full octet. The nonmetals, all the way on the right side of the table, they have valence numbers of 5, 6, and 7. That's almost full. They can share their way to a full octet. Metals have to transfer electrons to have an octet. Then they become charged positively, and then they attract to the nonmetal negative charge. That's ionic. They can't covalent bond. So, let's see, where were we? Let's look at the names first. Compound name. So beryllium iodide. Do you think that is an ionic compound or a covalent compound? Well, do you see any prefixes here? Is there a mono, di, tri, tetra, penta? Are there any prefixes here? No prefixes? Okay, that has to be ionic. Also, what is beryllium? Look at your table. Where is beryllium? It's in the alkaline earth metals, okay? So it's a metal, and there's no prefixes. Check, check, that's ionic. Ionic. Now, nitrogen trihydride. Nitrogen trihydride. Well, first of all, nitrogen is a nonmetal. Hydrogen is a nonmetal. And what do you see here? Trihydride. You see a prefix. Oh, this has to be a what? Covalent compound. Covalent. Now, look at the formulas. Silicon and oxygen. That's what's in this compound. Silicon and oxygen. Now, silicon is a what? That's actually a metalloid. Okay. Silicon, metalloid. Oxygen, nonmetal. This could be a little tricky. But is there a metal? No. So I'm going to go with covalent. There's not a metal. Covalent. Now, I will say, folks, there are exceptions. Okay, there are exceptions, but we're talking in generalities here. Okay, so in general, if there's a metal, ionic. No metal, covalent. Last one: lithium and oxygen. Lithium is an alkali metal, family 1, group 1 in the table. That's a metal. Bonded to oxygen, a nonmetal. So a metal and a nonmetal, that is ionic. So we at least have those identified. Now, why do we care to identify them? Because we don't know how to name them if they're not identified correctly. Because again, we don't use prefixes on ionic compounds. We do use prefixes for covalent. So, number one here, silicon and oxygen. What would be the compound name? Since we know it's covalent, how would we name it? Silicon and oxygen. Well, silicon would start the name. We don't use mono at the beginning. There's only one silicon, yes, but we don't use mono at the start, never. There's no subscript in the formula for silicon, and so no prefix, just silicon. Just the name. So silicon first. Now, subscript is what? 2, right? And 2 is di. So silicon, di what? Di. Now, it's oxygen, right? O is oxygen. And so how would we say that? If it's the second one in the name, remember, "ide," it gets the "ide" suffix. So oxygen is not oxygide, it's just oxide. Oxide. Dioxide. Silicon dioxide, okay? Now, beryllium iodide. It's ionic. What's the formula? Now, here's the thing. We don't have prefixes to tell us what the formula is. See, in covalent, the prefixes tell you what the formula has to be. We don't have that for ionic. So how did we do that? How did we figure out the formula just from names? Do you remember what we did? We had to look at a number. There was a set of numbers that was very important because it's ionic. There's a certain number associated with ions, which is their charge. And so what number am I talking about? I hope you're remembering the name of this thing. The oxidation number, the plus or minus charge, right? The charge number. So we have beryllium and iodine. So Be and I. Okay, what are the oxidation numbers here? What's beryllium's oxidation number? Hopefully you look it up on the table. It's an alkaline earth metal, so it's on group 2. So that's a +2. So you should be writing ion symbols for these. Then we can figure it out. Iodine is a -1. It's a halogen. It's all the way on the right side there in group 17. So question is, how can these combine to make neutral? There's only one way they can combine and make a neutral compound. How can a +2 and a -1 combine? You need what? 2 -1s, right? You need another -1. That means you need 2 iodines for 1 beryllium to make neutral. You need 2 -1s to balance out the charge on the +2. So it's going to be BeI what? BeI2. You need 2 of the iodines. Now, here's the thing. Again, we don't need prefixes for ionic because we have oxidation numbers. The oxidation numbers tell us how they have to combine. Now, to this one. Oh, it's another ionic one. So Li2O, how do you name that? Again, no prefixes, folks. It's an ionic compound, no prefixes. So the name is just the name of the positive ion and then the name of the negative ion. No prefixes. So this has to be what? What's the name of lithium positive ion? It's just lithium. Lithium. What is the name of oxygen as an ion? Oxygen as an ion name is oxide. Remember, we dropped the whole ogen, oxide. Now, how do we know that there's 2 oxygens, or excuse me, that there's 2 lithiums in this formula? Because we would have to look at the oxidation numbers and see that lithium is a +1 and oxygen is a -2. So we need 2 of the +1s to cancel the -2. So we'd have to do what we did for beryllium and iodine to know that that was supposed to be the formula, since this is ionic, and it doesn't tell us how many of each are in the formula in the name. The name doesn't tell us that. The oxidation numbers tell us that. I hope this is making sense. And lastly now, nitrogen trihydride. So it's covalent, which means we need prefixes. Now, there's no prefix in front of nitrogen, which means there's how many of them? One. So there's only one nitrogen. One. Trihydride. Tri means what? Three. Three what? Three hydrogens. Hydride, hydrogen. That's what that means. NH3. That's supposed to be a 3. Oh my gosh. Now, we will have a double quiz, one over the covalent and the ionic stuff. There is a review posted on Classroom. You need to try that, answer those things. It's kind of like what this table is doing. That's kind of what you do on the review. It's more of this practice stuff. Okay. We will talk about that on the next class, and then you will take the double quiz at the end of our discussion. Hope this helped, and I'll see you hopefully soon.